Ever wondered how data travels over the internet? It's a fascinating journey, and it all starts with something called an IP address. An IP address is a unique string of numbers and letters that identifies each device connected to the internet. It's like the home address of your device in the vast world of cyberspace. Now, there are two versions of IP addresses, IPv4 and IPv6. IPv4, the older version, is composed of 4 sets of numbers separated by dots, while IPv6, the newer version, includes alphanumeric characters and is longer. Due to the explosive growth of devices worldwide, we're gradually shifting from IPv4 to IPv6 to accommodate more unique addresses. So every time you send an email, download a file, or stream a video, your data is directed to and from your device's unique IP address. It's like a courier service, but for data. So think of an IP address as your online home, where all your data comes to and from. Now imagine if you lived in a huge apartment building. It would be chaotic if the mailman had to search for your apartment every time, right? That's where subnetting and supernetting come into play. Think of subnetting as the practice of dividing a large network apartment building into smaller, more manageable network floors. Each floor, or subnet, houses a certain range of IP addresses. This makes the management of these addresses easier and more efficient. It's like having a mailman for each floor. On the flip side, supernetting is like merging smaller network buildings into a larger one. It's the process of combining smaller networks into a larger network, making it easier to manage as a whole. Imagine having a single building manager overseeing multiple buildings. Both subnetting and supernetting are crucial strategies in the world of networking. They help maintain order amidst the vast number of IP addresses and networks. With subnetting and supernetting, managing data traffic becomes much more efficient. But who decides how your data gets to its destination? Enter routers and routing. Routers, my dear friends, are the unsung heroes of the information superhighway. Picture them as the traffic directors of the internet, meticulously deciding the best path for your data packets to take, ensuring they reach their destination swiftly and efficiently. Now imagine the internet as an enormous city, sprawling with countless roads and highways. Your data, akin to a traveler, needs to navigate this intricate network, but without a map or a GPS, how does it know which way to go? That's where routing comes into play. Routing is the process of selecting the most optimal paths within a network along which to send network traffic. In simpler terms, it's like your data's very own GPS system, guiding it through the vast digital landscape of the internet. Routers and the routing process work in harmony to facilitate this. When your data arrives at a router, the device scrutinizes the information, deciding the most efficient route based on various factors such as traffic congestion and distance. It's a complex and dynamic process, with routers constantly communicating and updating each other about the conditions of their respective routes. This ensures that your data can always take the quickest and most efficient path to its destination, much like a savvy driver avoiding traffic jams and roadworks. So routers are like the traffic cops of the internet, always ensuring data finds its way home. And how do these routers know the best path to send your data? They follow the rules set by routing protocols. Now let's delve into some of these common routing protocols, starting with OSPF, or Open Shortest Path, first. This is a link state routing protocol, which means it gets a complete picture of the network's topology. OSPF uses an algorithm called Dijkstra's algorithm to calculate the shortest path between 2 points. Next up, we have eGRP, Enhanced Interior Gateway Routing Protocol. This is a Cisco proprietary protocol and functions on a slightly different principle. eGRP is a distance vector protocol and uses a metric system to determine the best path for data transmission. It's like giving your data a GPS system to find the quickest route. Lastly, we have BGP, Border Gateway Protocol. This is the protocol that makes the internet work. It's the granddaddy of all routing protocols. BGP is vital for ensuring all the different networks that make up the internet communicate effectively with each other. Each of these protocols, OSPF, eGRP, and BGP, have their unique ways of ensuring your data takes the most efficient route from your device to its destination and back. They are like the traffic cops of the digital highway, ensuring that your data doesn't get stuck in a traffic jam or take a wrong turn. And there you have it.
from your device to the wider internet and back again. That's the journey your data takes.